Excuse me, ma'am.
Ma'am is not there.
Is this a extra class?
I don't think.
Then this is not marked in the timetable.
Ma'am told na that day that she will be taking one more class, but she don't know. I think this is the one.
नहीं ये सही है यार इनको कभी भी घुस जाओ अंदर.
ये recording चालू है.
So what will be the class in the evening? Is that class cancelled or is that also being conducted?
कभी आज इवनिंग में तो क्लास नहीं है.
है ना 3 से
अबे
350
है बे।
क्लासेस है.
अरे वो नहीं है. आज नहीं है. 3 से 350 कोई क्लास नहीं इलेक्ट्रिकल की. आज
ये
2:10 से 3 तक ही है लास्ट क्लास.
ये कौन सा टाइम टेबल देख रहे हो यार तुम लोग?
देख ले तू. वो सर ने
क्लास है ना।
भेजा है वो गलत है. सब सब फैकल्टी ने कंफर्म कर लिया है ना क्लास है वो. सर ने भेजा है वो गलत है.
ई कैंपस पे तो कुछ और ही टाइम टेबल चल रहा है, इधर कुछ और चल रहा है.
वो तो पूरा अलग ही है. एक्सक्यूज मी मैम. हेलो मैम.
See, for your information, I can take any class I wish. Okay, either morning session or afternoon session, 11:40 to 12:30 or 3:30 the class. Okay. If I take
So
morning
that
class,
is,
afternoon will be
ma'am,
free. If I take afternoon class, morning class will be free. All are
ma'am, that
BEEE
is,
slots only.
excuse me, ma'am, that is okay, but we have to know prior to that class, na, if the class is being taken. That's what the timetable is for.
Ma'am, but that day you told na at afternoon there will be no any class today.
Somebody share the class link in WhatsApp group also. Maybe some people do not know. All are able to hear me out?
Yes, ma'am.
Oh, yes, ma'am.
Yes, ma'am.
Ma'am, is there class at evening?
Ma'am,
Are
then
you
how
able to
we'll
hear me?
come to know that when we have the class at morning or at afternoon?
Somebody should tell me is my voice audible or not.
Yes, ma'am.
Excuse me, ma'am, please, before starting the class, can you confirm us a timetable when is the classes being conducted?
I'm not able to hear you properly.
Ma'am,
Ma'am,
can
we
you
can
please
hear you.
confirm us the timetable when the classes are being conducted? Because this will be a very big chaos if we don't know the time.
Yes, ma'am. Please confirm.
I think ma'am is not able to hear us.
Okay, shall we begin the class then? Let the others join in later.
Yes, ma'am.
Yeah.
Okay, ma'am.
But did you speak?
Yes, ma'am.
See, you should see the chat messages or whatever things that I'm telling you. Are you hearing me out or not? Today we are having two BEEE slots. Okay, if I take morning session, afternoon session will be free. If I take afternoon session, morning session will be free. Okay, it's my will and wish to take any session, whichever I wish. Understood, Suraj?
Ma'am, that is okay on your side, but we also need to know the timetable so we can
Really, I'm not
prepare
able to
things.
hear you at a louder voice. I don't know what's the problem.
Ma'am, can you just confirm the timetable when it will be?
Ma'am, I think there's a issue from your side.
What? Yeah, I'm able to hear you, but feeble. I'm not able to hear you full.
Ma'am, then you connect and rejoin, I guess.
Okay, anyways.
Ma'am, rejoin, ma'am.
Okay, we'll begin the class. Okay. So yesterday or the previous class, what were the category of transducers we were discussing? Just name the transducers we were dealing with the last class.
Optoelectrical transducer.
What?
Optoelectrical, ma'am.
Okay, electro-optical transducers, different types. We are discussing LED, photodiode, phototransistor, and then solar cell, and so many other types we were discussing. All right, today's class we are going to discuss temperature type of transducers. That is, we are going to discuss thermocouple, thermistor, resistance temperature detector, etc. I think in your physics class you must have studied Seebeck effect. Do you remember? Seebeck effect, have you studied in your physics class and do you remember?
No.
What, Mudimala? I'm hoping you must have studied about Seebeck effect in your physics class. Okay, so based upon the Seebeck effect only, the thermocouple is working. All right, thermocouple is working. This is one type of the temperature transducer. Today's class, we are going to discuss only about temperature transducers, and if time permits, one or the other two types we are going to discuss. Under temperature, you are going to discuss thermocouple. Then we are going to discuss RTD, that is resistance temperature detector, and thermistor. These three are included in your syllabus. So these three we are going to discuss, starting with thermocouple. So this is the diagrammatic representation of your thermocouple. Okay, it works on Seebeck effect. Okay, Seebeck effect. All right. And as per Seebeck effect, you need to have two metals which are very, very different. All right, two dissimilar metals. Combination, for example, this might be asked in MCQs. You can take the case of iron and constantan, or you can have a chromal alumel combination. Okay, so these are two different metals, okay, which are quite different. You are going to put them together via wire like this. Okay, two different metals, two dissimilar metal wires you are going to consider. Depending upon the temperature that we wish to measure, the range, okay, we are going to choose either iron and constantan combination or chromal alumel combination, and you are going to connect them with the help of a wire like this. All right. So Seebeck effect means, suppose if you are having such a combination of a thermocouple, then from one side there are two junctions that will be formed. If you are joining these two dissimilar metals, one will be the measuring junction and the other one will be the reference junction. So with respect to the reference junction only, we will be measuring temperature at one end. So here the temperature will be measured, and as usual, reference junction, you will be having a zero condition, reference condition, base condition, nominal condition. Now, as per Seebeck effect, from one end, you are going to give a heat source. All right. We are going to induce a heat source. So because of this heat that is induced at one junction, this particular junction will become hot. Okay, because of which there will be flow of electrons. So electrons will start to flow, and that will try to flow from the hot junction towards the cold junction, which is having a lower temperature. So because of this difference in temperature, there will be an equivalent voltage that is developed, or potential difference that is developed, that will be measured by this voltmeter. So here the energy conversion that happens is the temperature difference that we want to measure, that will be converted into an equivalent voltage. So by measuring the voltage that is indicated in the voltmeter, we will be able to measure out the temperature. All right. So this is how thermocouple works. All right. Now you people should tell me where you are going to apply this thermocouple arrangement. Give me some proper answer. Just type in the chat box, okay, because I'm not able to hear you properly. You could type some answers where we'll want to measure the temperature. Some simple applications or complex applications. Whichever application is involving with the temperature, or increase the
Ma'am,
temperature or decrease
it can
the
be
temperature.
used as sensor where temperature is involved.
Where temperature is involved, Tambe?
Ma'am, engines in
Where?
which the ma'am in car engines
Car
where
engines.
where the
Okay, car
near
engines
the
is one
speedometer there is
example. Then any other examples?
a
Manufacturer of steel. In what way? What happens in the steel industry? Suraj. What process happens in a steel industry?
turbines.
Turbine. Okay, gas turbine, gas engine. Any other simple example?
Ma'am, it can be also used to detect fire.
Detector
The
fire.
temperature आ
Then
जाए.
simple example is your microwave oven. Okay. So
Okay,
you
ma'am.
must have heard of oven, no? Microwave oven.
Yes, ma'am.
Yes,
You are
ma'am.
setting temperature at a very high value. Okay, and you are cooking things via microwave oven. That is a very simple example where you want to keep a check on the temperature. Okay, there also you can make use of a thermocouple or any other temperature transducer like this. So many examples are available. All right. Plus another simple example is a battery. All right. You want to charge up a battery. Sometimes the battery temperature may go high, which may affect its performance. So you want to put a check on the temperature of the battery also. So in all these applications, you might want to check the temperature now and then. For all these applications, you will use one or the other temperature transducer. The temperature transducer may be a thermocouple or a thermistor or a resistance temperature detector. All right. So again, thermocouple works on what effect? What is the effect? Just now I told you it works on what effect?
Seebeck.
Seebeck.
Seebeck effect. Okay, what is the Seebeck effect actually? You are going to combine two different metals. Okay, not the same metals. Two metals which are having quite different characteristics that you are going to combine by means of a conducting wire. All right. So the two junctions will be formed. One of the junction will be called as a measuring junction. Other one will be called as a reference junction. So from one junction, you are going to induce a heat source, whichever you want to measure. All right. This might be any sort of application where you want to measure the temperature. So if there is a heat source here, this junction will get hot. All right. So when it becomes hot, with respect to this reference junction, here the temperature will be slightly high. So now, because of this temperature difference, there will be flow of electrons via this wire that is joining these two dissimilar metals, and thereby voltmeter will be day one voltmeter will be measuring the potential difference. So by measuring the potential difference, you will be able to measure the temperature difference. Okay, this works on the basis of Seebeck effect. And what are the metals that can be used? That is important because that might be asked in MCQ. So again, I'm telling you, you can have a combination of iron and constantan that is working around temperature range of 70 degrees C. Or suppose if you want to have a slightly higher range of temperature measurement, then you should use chromal alumel combination. All right, make a note of it. That is not given in the PPT. So applications, as I told you, you can use it in gas turbine, diesel engine, or any other safety devices. And this is quite simple and it is quite accurate. And the thermal reaction happens very fast because of the Seebeck effect. So those are the very many advantages that is seen in the thermocouple. So this is one good example for a temperature transducer. Next comes your thermistor. Okay, thermistor. Thermistor is also a temperature transducer, but here it is also called as a thermal resistor. So what will happen to the resistance with respect to the temperature? This is a thermal resistor. So resistance and temperature are the terms that are involved here for the measurement of temperature. So whenever there might be a temperature change, temperature varies means accordingly the resistance will vary. If resistance is varying means the current flow will vary, and which will be resulting in the potential difference variation that will be measured, with the help of which you will be able to calculate the temperature of the particular application. So there are two types of thermistor, as you can see here. One is negative temperature coefficient thermistor and the other one is positive temperature coefficient thermistor. Suppose if it is a negative temperature coefficient thermistor, okay, negative, all right, negative temperature coefficient, then resistance and temperature will be inversely proportional. So if temperature is reducing, resistance will be increasing and vice versa. If temperature is increasing, resistance will be decreasing. This is called as negative temperature coefficient thermistor, and it is most commonly used when compared to positive temperature coefficient. But on the other hand, if you see to this positive temperature coefficient thermistor, both resistance and temperature will be directly proportional. So whenever there is an increase in the temperature or decrease in the temperature, accordingly there will be an increase or decrease in the resistor. So these are the two types of thermistors that are commonly seen. but comparatively you will be usually using negative temperature coefficient only. And for making up the temperature measuring element, you can use cobalt, nickel, chromium. These are the common elements that are used for sensing the temperature. So this is all about thermistor, which uses resistance variation in measuring the temperature. Now if you see to the circuit symbol, this is your circuit symbol for positive temperature coefficient thermistor and negative temperature coefficient thermistor, and the characteristics with which the resistance varies with respect to temperature, that is shown for the thermistor here, both for positive temperature coefficient and for negative temperature coefficient. All right, and the common elements that can be used is cobalt, nickel, so on. So many other elements are there. Okay, and how this works is because whenever there is a change in the temperature, then there will be a change in the resistance. With the help of the change in the resistance, there will be a variation in the current flow, which will be leading to some voltage difference that will be measured at the output side. So this is again an electrical transducer, which converts temperature difference into an electrical quantity. All right. So this is all about thermistor and the various applications. For example, digital thermometer, automotive applications, microwaves, fridges, ovens, surge protection batteries, as I already told you, Wheatstone bridge, for measuring thermal conductivity of electrical materials. Okay, for all these cases, you can make use of this thermistor. And finally, you are having a resistance temperature detector. Wait, let me load the document. Okay, so this is also called as what type of transducer? You can check out now. What type of transducer is a thermistor, thermocouple, RTD and all? You are able to see the screen, huh?
Thermoelectric.
Ma'am, they are optocouplers.
You are not able to see the screen. Now it's coming on. So what is the name that is given for all these type of transducers?
Temperature transducer.
Thermoelectric.
Thermoelectric.
Okay,
Thermoelectric.
because this is converting temperature difference into equivalent electrical signal, these are coming under thermoelectric category. As I told you, thermistor, I told you the relation also, resistance is inversely proportional to temperature. And the circuit symbol, I told you, the relations on the basis of which the temperature is related to resistance, that is given here. These are not needed for your study. Only you understand how it works. Okay, this is the circuit symbol. This is your characteristics that I have just showed you. Only you need to remember the materials that are used here: cobalt, nickel, copper, iron, uranium, etc. All right, again, this is your thermocouple. Where the output of the thermocouple will be in microvolt range, so that will be a very weak signal. So you surely need an amplifier to make it strong. So that will be added at the output end. And what are the elements that you commonly use is iron constant and chromal, alumel. And finally, your resistance temperature detector. Okay, resistance temperature detector is the last type of temperature transducer that we are going to discuss. So all are able to see the picture. The picture is not properly labeled, but I will tell you in words so that you can understand the diagrammatic representation. So what is the name of this transducer? What is the name of this temperature transducer?
Resistance temperature detector.
அதான் மேம் நான் கல்யாண சட்டை கேட்டேன் மேம். அவர் சொன்னாரு அது யூஎஸ்பில சேஞ்ச் பண்ண மாட்டாங்களாம். நம்மளுக்கு என்னவோ அது ஒரு நாள் மட்டும் தான்.
Ma'am, your voice is echoing. We can't hear you.
ஒரு நாள் மட்டும்தான் மாறும். அந்த டே 2 வரல, அது டே 6யோ டே 5யோ நான் போடல போல. டே 3 இன்னைக்கு ஈக்குவல் உங்களுக்கு மத்தியானம் வரும், எனக்கு காலையில வரும் நினைக்கிறேன். அந்த டே 2 மட்டும் எனக்கு டே 5லயோ 4லயோ போடணும். நம்மளுக்கு டே 2 இப்பதான் கிளாஸ் வராது அப்படின்னு நினைக்கிறேன். டே 2ல எனக்கு வராது, டே 6 அதனால அது நான் டே 5லயோ இதுலயோ போடணும்னு நினைக்கிறேன். I'm டே 6. Okay, people, let me rejoin. That is better. Let me try. Okay, people, somebody give me the answer. What is the name of this temperature transducer? People can hear me now?
Resistance temperature detector.
Okay. Now I am able to hear you properly. Very good. Okay, resistance temperature detector. All right. That is also one type of thermoelectric transducer. Now there are two types that you can have under this category. One is lab type and the other one is industrial type. Okay, this industrial type of the temperature detector is usually termed as resistance temperature detector. The working and all will be almost the same. Constructionally, slight difference only will be there. All right. So the industrial type of temperature detector, that is called as RTD, that is resistance temperature detector. There is another category which will be usually used in lab. Both will be constructionally almost the same with only 1% or 2% difference only. How that differs, I will tell you now. Okay. Now again, this is also working with what type of relation? Tell me. Thermocouple means it works on Seebeck effect. Thermistor means the relation between resistance and temperature will be used up. What about resistance temperature detector? Again, easy question. How are these related? Resistance and temperature. How the temperature difference is measured? By using what variation again for an RTD? You heard me out or not? There's a slight delay in my voice. People, could you hear me or not? I think you could. You people are there in class or not?
Yes, ma'am.
Then tell me what variation will lead to the measurement of temperature. If it is a thermocouple means Seebeck effect. If it is thermistor means you will be measuring temperature with the help of variation in resistance. If it is an RTD means what will happen? How will you be able to do the temperature measurement? Okay, some of your voice I'm hearing, but some I'm not hearing. Okay, anyways. Alright, resistance again, the variation of resistance only will be used here also to
Resistance
measure
with variation of temperature.
resistance with the variation in temperature here also. Okay, so how much there will be a percentage degree centigrade difference that will be resulting in resistance of the metal variation, with the help of which you will be measuring the temperature. And as I told you, there are two types here, lab type and one more type, that is industrial type. Industrial type is commonly called as resistance temperature detector. And you can see here what is a popular metal that you are going to use up here, whose variation in resistance you will be using to measure the temperatures.
Platinum.
What? Platinum. Okay, platinum here you are going to use. Okay, the metal that you are going to commonly use for an RTD is platinum, with the help of which you will be measuring out temperature. Okay, and again I told you there is a lab type and the other one is industrial type. The industrial type is commonly called as RTD, that is resistance temperature detector. Constructionally, how will it appear? That is the question. So this platinum will be arranged in terms of a wire, okay, helical wire, which is doubly wound around some former, and it will be kept inside a glass enclosure. So this is a common constructional arrangement that is seen for a lab type as well as industrial type, but only small difference, the type alone will be differing. So the common constructional arrangement is you are going to take a metal, preferably the metal will be platinum. Okay, preferably the metal will be platinum, and you are going to wind it double helical, and you are going to fix it around a former, and the whole arrangement you are going to fix it inside or keep it inside or assemble inside a glass enclosure. Okay, so this is how the constructional arrangement will be looking like. Suppose if it is a lab type you assume, then the temperature sensing coil is wound on what type of former? What type of former? Former means nothing but one simple arrangement around which you are going to wind the wire. So what type of former is used for lab type RTD?
Mica cross.
Mica.
Mica.
Mica. Okay. Then it will be placed in what type of glass tube? What type of glass tube? Pyrex. Okay, Pyrex, and that whole glass tube will be filled with gas or evacuated for protecting that aluminum. This way, if you are constructing means that will be called as a lab type. But if you are going for industrial type of thermometer, that will be called as what?
RTD.
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 What is the expansion for RTD? Resistance temperature detector. So if you see to its construction, again it is also made up of platinum, doubly wound helical. They will be wound in grooves. And what type of former is used here? For lab type it is mica former. But here what is the former type that is used? What type of
Ceramic.
former? Ceramic.
Ceramic.
Okay, ceramic former. Again it will be enclosed in what type? Glass coating only, or stainless steel tube. Okay, you can keep it in the glass coating or stainless steel tube. So this is how constructionally the thermometer arrangement will differ. Industrial type thermometer, it is commonly called as RTD. All right. So you have seen thermometer, na? Yes or no? Nowadays they are not using glass thermometer, but olden days, in your father's days or in your parents' days, you must have seen your thermometer, na?
Yes, ma'am.
So it Made up of glass bulb or not?
Glass.
Yes, same thing. So this is thermometer, but industrial type of thermometer specially called as resistance temperature detector. So the first one, this is your lab type. Okay, I told you lab type. In both cases, you will be using platinum as a wire sensing coil. It will be doubly wound. Okay, doubly wound, helical shape, and you are going to place it inside a mica frame here, and you are going to place it in glass. All right. But if it is to be a resistance temperature detector means doubly wound helical groove like shape you will be winding, but here you will be using a ceramic former. All right. And again, you will be placing it in either a glass enclosure or you can use a steel enclosure. This is called as resistance temperature detector. Okay, so the three types of temperature thermoelectric type of transducers that you discussed in today's class, what are the three types? What are the three types of temperature transducer or thermoelectric transducer we have discussed in today's class?
Thermocouple, thermistor, RTD.
Thermocouple, then thermistor, then finally we have discussed RTD.
RTD.
Common thermometer, industrial type of thermometer is called as resistance temperature detector. The first one works on what effect?
Feedback.
Feedback effect. So how the construction will look like? You are going to use two metals which are quite different, preferably iron constant and combination or chromal aluminum combination, and you are going to combine them both using a conducting wire so that two junctions are formed. One will be called as a measurement junction with respect to which you will be measuring the temperature. Other junction will be called as a reference junction, which is usually at zero temperature. So the measurement junction only will be connected to whatever application whose temperature you are going to measure. All right. So in that case, if there is a slight increase in temperature, it will be acting like a heat source. So at that particular junction, the junction will become slightly hot. So with respect to the other junction, which is at cold state, there will be difference in temperature. So because of this temperature difference, you will be having a flow of electrons in between, which is commonly measured by a voltmeter in terms of PD. So if it is a thermistor or an RTD means how the temperature will be measured? How temperature is measured in an RTD or a thermistor?
Variation with temperature.
Yeah, variation in temperature. So what is the difference between negative temperature coefficient and positive temperature coefficient transducer? Negative means resistance will be in what way related to temperature?
Inversely proportional.
So temperature increases means resistance will drop down and vice versa. And the common elements that are used is cobalt, nickel, chromium, so on. Suppose if it is positive temperature coefficient means how these two elements will be related? Resistance and temperature will be directly
Proportional.
Okay. So then RTD means it's a common thermometer only that you have commonly used in olden days. But lab type means it will be simple. But if it is an industrial type means usually what element are you going to use in both cases? The temperature sensing element will be a metal which is commonly what?
Platinum.
Platinum. Okay, and you are going to wind the platinum in double helical grooves and you are going to keep it in a ceramic former, and then the whole thing will be assembled inside a glass bulb or a stainless steel tube enclosure that will be used for measuring temperature in industries, big industries. So that way it will become a resistance temperature detector. And common applications where you need to measure temperature or what? Applications, I told you, no, whichever applications where you want to measure temperature. Some applications, just now I told you, no.
Microwave oven,
Oven, then fridge,
freezer engine, gas turbine.
gas turbine, then battery, all right, thermostat, digital thermometer. So many applications are there. Okay, wherever there might be a chance where the temperature might go high, even for a motor, if you want to measure temperature, you can use it because when it rotates now, it will become hot and it will dissipate loss. At that time, its temperature will go high. So you want to measure the temperature. So there also you can use some sort of temperature transducer. All right. One more electro-optical type of transducer I have left out, that is LCD. So what is the expansion for LCD? Almost all must have learned what is the application of LCD. What is
La-
LCD? What?
Liquid crystal display.
Yes, liquid crystal display. So where will you use this LCD?
TV. Screen monitor.
Yes, nowadays LCD TVs are coming up. Then apart from LCDs, TVs, which are the simple applications? You have used calculator. Okay. In calculator, what type of display is there? In your laptop, in your mobile device, touch phone and all. Touch phone, touch laptop. When you touch it, what happens there on the screen? Touch phones, when you touch the screen, what
Yes,
happens?
ma'am. Bubble like
Liquid flows.
Yes,
It-
there is a liquid crystal. So those will be using liquid crystal displays. Okay, so you need to know how that happens and how that crystal action happens to emit the light. Okay, that is one type of electro-optical transducer only that I have left out. So let me finish that. So if you see a liquid crystal, means it's a combination of two states of matter, that is solid plus liquid. Both will be combined to give a liquid crystal. And as you already told you, it is commonly used as touch screens in computers, TVs, mobile phones, so on. And it is having so many advantages, like it consumes very less power, very less voltage, so on. So because of which people are preferring for LCD displays. Now, if you see to the construction, in the center, all are able to see the construction now.
yes, ma'am.
Okay. In the center, what you are having, this is your what? That I am pointing out, that is called as what?
Liquid crystal layer.
Liquid crystal layer. Okay, that is a combination of solid and liquid. And on both ends, you are having electrodes, negative electrode and positive electrode. Preferably, it is a tin oxide electrode. And after that electrode layer, what you are having here?
Glass filters.
Glass filter. And then afterwards, you are having mirror arrangement. Here it will be a display. So this is how a liquid crystal display will be having a constructional part. And you need to know one important thing. This liquid crystal, okay, this is your liquid crystal at the centerpiece. So that liquid crystal is originally transparent. So you know what is the difference between transparent and opaque? So what is transparency and opaque? Opaqueness.
Ma'am, opaque means we can't see through it, and transparent means we can see through it.
So originally, this LCD, that is crystal, will be transparent. So it will be allowing twisting of light. Okay, so it will be allowing free flow of light in original condition as long as there is no supply to it. Okay, as long as no current passes through that liquid crystal, it will remain transparent only, so that it will allow twisting of light. Okay, but sometimes you want to have a display. Okay, at the output end, you can see this is your display screen. So I want some letter or alphabets or numerics to display. So at that time, electric current will flow through this crystal or not? Yes or no? When you want some display action, the liquid crystal will be activated. So it will start to have some electric current flow or not?
Yes, ma'am.
Yes. So when that electric current starts to flow, earlier the electric field will be very weak. So the crystal will be originally transparent. All right. Now there is an electric current flow. The electric field becomes very strong. So the liquid crystal molecules which were already allowing twisting of light, now it will stop. The whole structure will collapse. Okay. Now the molecules will untwist. All right. So no more twisting of light will be allowed. All right, so the crystal will turn to opaque. All right, opaque means what? It will block light. So now the display will be possible. Okay, whichever places there is opaqueness, it will be displaying image. So this is how a liquid crystal display works. So now you have to tell me how it works. Tell me again how it works. With that we will close class today. How a liquid crystal display will work in simple words. How a liquid crystal display will work? In the center, you are having a liquid crystal. Okay, this is your liquid crystal, which is a combination of two states of matter, a solid and a liquid. On either end, you are having electrodes, one positive and one negative, preferably tin oxide it will be. Okay, and sandwiching that, it will be having a glass filter, and then you will be having a polarizing film, and finally mirror at the back and the display image at the front. Okay, and how it works is, originally this liquid crystal will be having what nature?
Transparent.
Transparent. Okay, originally it will be transparent. The transparency means it will freely allow twisting of light. Okay, twisting of light, and there will be no electric field. The electric field will be very weak, no current flow, nothing is there, no displays required. So the liquid crystal will be transparent, it will allow free flow of twisting of light, and the molecules will be aligned in that particular manner, and the electric field will be weak. Now, second case, you want some display action to happen. So once this display action is to be happening, then that liquid crystal will get activated. So electric current will start to flow. The field will become strong now. Okay, so the earlier twisting of light, now it will stop. So now it will be resulting in untwisting of light. Why? Because this liquid crystal will lose its structure will collapse. Earlier it was transparent, now it will lose its transparency, its structure will collapse, its molecule alignment will become different, because of which it will become from transparent to what state?
Opaque.
Opaque. Okay, so it will block light. All right. So whichever spaces are being blocked from light, those spaces will display. All right. Alphabets or numerals. So this is how liquid crystal display will work. All right. Understood liquid crystal display? Huh?
Yes.
Okay. All right. Next one, electrometer. This is one simple thing. Electrometer means, as the name suggests, what will it measure? What will it measure?
Potential.
Electric potential difference or charge it will measure. So the instrument construction is shown here. Generally, this is your electrometer. So it will be electrically equivalent to what? Combination in parallel. You are going to measure charge or potential difference. Okay. Wherever you want to measure PD or charge, you are going to use an electrometer. So the electrometer, inside the meter, you will be having an equivalent which is representing that I have circled. So it is generally what actually? What meter? What meter is this?
Voltmeter.
Voltmeter in parallel with one capacitance. So this capacitance will be considered its internal capacitance. Okay. So this is your internal capacitance of this voltmeter. So this is how the electrometer is electrically equivalent to. Now the second circuit, if you see, means this is your meter. Okay. This is your electrometer, which you are going to connect it to whichever element whose PD or charge you want to measure. Suppose if you want to measure the charge of this external capacitance, so you connect the meter parallel to it, and by using what equation you are going to measure the charge? Q is equal
Capacitance.
Q is equal to CV. All right. Suppose if that capacitance whose charge you want to measure, that itself is having its own capacitance, means you just add that capacitance to it. So that's all. So the basic equation that you are going to use up is Q is equal to CV only. So this meter is called as what meter? What is
Electrometer.
Electrometer.
What is the use of this electrometer? It is basically used to measure Q or PD. Okay, charge or potential difference of whichever element you want to measure. In order to do that, you are going to use an electrometer. Electrometer, although constructionally outside it looks like this, inside if you see electrically, it will be equivalent to a voltmeter in combination with an internal capacitance only. So whichever element whose charge or PD you want to measure, you connect this meter parallel, and using Q is equal to CV, you will be measuring charge. Okay, this meter is called as what meter? Electro
Meter.
Okay, so with this, shall we stop class, or one more type, Hall effect transducer we will discuss? We'll stop class with this. Okay, remaining 6 transducers are there: antenna, receiver, Hall effect, magnetic cartridge, Geiger-Muller tube. With that, this unit will be over. I think in one more class I will finish this unit. Okay, with this, all can disperse.
Thank you, ma'am.
Thank you, ma'am.
Okay, ma'am.
Thank you, ma'am.
Okay, ma'am.
Thank you, ma'am.
Okay.